For 50 years, one record has stood untouchable: Mach 3.3, the SR-71 Blackbird, the fastest jet-powered aircraft. Until now, the Boeing F-47 doesn't just redefine sixth-generation combat, it's coming for the crown. And its secret weapon? The most advanced jet engine humanity has ever created. March 21, 2025. The Oval Office. President Trump stands before the cameras with a grin that says he knows something we don't. Boeing had just won the contract for America's next fighter, the F-47, and Trump didn't hold back. This aircraft has the most power of any jet of its kind ever made. The speed? We can't even tell you the exact numbers because it would reveal too much about the technology. But I will say this: it exceeds Mach 2 by a lot. When the President of the United States can't tell you how fast something goes because the number itself is classified, that's when you know something extraordinary is happening. The designation F-47 wasn't random. It honors the legendary P-47 Thunderbolt that dominated World War II skies. But it's also a nod to the 47th president himself. And unlike most defense programs that exist only on PowerPoint slides, the F-47 has been flying in secret since 2020. Test aircraft, hundreds of flight hours, real data, real performance. Boeing has invested $1.8 billion building a massive production facility in St. Louis. The first production F-47 is being manufactured right now. Most fighter programs take decades. The F-47 program is moving at warp speed, and there's a reason for that urgency. To understand why the F-47 could be the fastest fighter jet, you need to understand its heart, the engine. And this isn't just any engine. The adaptive cycle game changer. Two companies are locked in competition: General Electric with the XA-102 and Pratt & Whitney with the XA-103. Both are adaptive cycle engines, technology that's straight out of science fiction. Here's how traditional jet engines work. They're optimized for one thing: either maximum thrust for combat or fuel efficiency for cruising. You can't have both. It's a fundamental compromise that has limited fighter design for 70 years. Adaptive cycle engines shatter that limitation. These engines have 3 streams instead of the traditional 2. They can physically reconfigure themselves mid-flight. Need maximum thrust for combat? The engine morphs into high thrust mode, channeling all airflow for pure power. Need to fly 1,000 nautical miles without refueling? It switches to high-efficiency mode, optimizing for range. The performance numbers are staggering: 45,000 pounds of thrust. That's 10% more than the most powerful fighter engines currently in service. 25% reduction in fuel consumption compared to F-22's engines. 50% improvement in thermal management over 5th-generation engines. Sustained supersonic cruise without afterburner. That last one is critical. The F-22 can supercruise at around Mach 1.8. But the F-47? With adaptive cycle technology allowing continuous supersonic flight without the massive fuel consumption of afterburners? We're talking about sustained speeds potentially exceeding Mach 2.5. Digital engineering at light speed. But raw power isn't enough. Pratt & Whitney and GE are using something called digital twin technology to develop these engines. They've created complete virtual replicas. Every component, every airflow pattern, every thermal signature, and tested everything in simulation before building physical prototypes. This approach has compressed development timelines by years. Traditional engine development could take 15 years. The XA-102 and XA-103 programs, they moved from concept to ground demonstrators in less than a decade. The thrust-to-weight equation. Now here's where things get really interesting. Based on leaked specifications, The F-47's adaptive engines produce around 35,000 to 40,000 pounds of thrust per engine. The aircraft uses two engines. That's potentially 70,000 to 80,000 pounds of combined thrust. Analysts estimate the F-47 has a loaded weight around 45 tons, similar to the old F-111 strike aircraft. That gives it a thrust-to-weight ratio exceeding 1.2 to 1. For comparison, the F-22 Raptor has a ratio of about 1.08 to 1. More thrust, less weight, advanced aerodynamics. This is the formula for extreme speed. The untouchable record. On July 28, 1976, SR-71 Blackbird pilot Eldon Jors pushed his aircraft to Mach 3.3, 2,193 miles per hour. That record has stood for 50 years. No operational jet-powered aircraft has come close. The fastest fighter jet currently in service? The F-22 Raptor at Mach 2.25. The Russian MiG-31 can briefly touch Mach 2.83 but can't sustain it. Even experimental aircraft have failed to break the Blackbird's record. Why the F-47 could be different. But the F-47 isn't designed like any fighter before it. And here's where speculation meets engineering reality. Trump said the F-47 exceeds Mach 2 by a lot. Defense analysts have picked up hints that the classified top speed might approach or exceed Mach 3. That would put it in Blackbird territory. The SR-71 was designed in the 1960s with slide rules and wind tunnels. The F-47 was designed with supercomputers and AI-assisted optimization. That's a 60-year technology gap. The Pacific Theater requirement. There's a strategic reason the Air Force might want extreme speed. The F-47 is designed for the Indo-Pacific Theater, vast distances, Chinese anti-access area denial systems that can reach hundreds of miles. Speed isn't just about breaking records. Speed is survival. The faster you are, the less time enemy sensors have to detect you. The less time missiles have to intercept you. The deeper you can penetrate into contested airspace. A fighter that can sustain Mach 2.5 or higher dramatically compresses enemy reaction times. It forces adversaries to completely rethink their defense networks. Could it actually break the record? Here's the honest assessment. Breaking the SR-71's record in operational service is unlikely. The Blackbird was purpose-built for speed above all else. It wasn't a fighter carrying weapons and engaging in combat maneuvers. But here's what's possible. The F-47 could become the fastest operational fighter jet ever built. And in controlled test conditions, clean configuration, optimal altitude, maximum thrust, it's not impossible that a test pilot could push an F-47 past Mach 3.3. Would the Air Force publicize such a record? Probably not. Speed performance is one of the most closely guarded secrets in military aviation. But the capability would exist, and that changes everything. The engine is revolutionary. The speed is potentially record-breaking. But the F-47 is more than just a fast jet. Combat radius, 1,000 plus nautical miles. That's 70% better than the F-22. It means the F-47 can fight deep inside enemy territory while keeping vulnerable tankers safely distant. Stealth++, next-generation all-aspect broadband stealth, reduced infrared signature, advanced electronic warfare systems. This aircraft isn't just hard to see, it's designed to be virtually undetectable. AI quarterback. The F-47 can command up to 1,000 autonomous drones, collaborative combat aircraft that extend its sensors, carry additional weapons, and multiply its combat effectiveness by orders of magnitude. Modular architecture. Open systems design means the F-47 can be upgraded rapidly as technology evolves. New sensors, new weapons, new software, all integrated on accelerated timelines. The competition is watching. China has already unveiled its J-36 sixth-generation fighter. They've been flying it openly, letting the world see their capabilities. Meanwhile, the F-47 remains America's best-kept secret. Russia claims the Su-75 and Su-57 programs are advancing. But none of these aircraft have confirmed adaptive cycle engines. None have the combat radius of the F-47. And none have the massive industrial and technological foundation that Boeing and the U.S. Air Force have built. What happens next? 2028. First operational F-47 takes flight. Late 2010s. Initial operational capability. 2030-10s. Full production ramp-up with 185 aircraft planned. The program is part of a $20 billion next-generation air dominance initiative. Boeing has one shot to deliver on time and on budget. No delays, no cost overruns. The stakes? American air superiority for the next 50 years. The F-47 isn't just about having the best fighter. It's about maintaining the strategic advantage that has kept major conflicts from escalating. It's about ensuring that no adversary believes they can challenge American air power and win. And if that means building a fighter jet that can potentially shatter speed records while commanding AI drone swarms and penetrating the most advanced defenses on Earth, that's exactly what Boeing and the Air Force are doing. Somewhere in the skies above California and Nevada, test pilots are already pushing the limits. They know how fast it really goes. They know what it can really do. By 2028, the rest of us will find out. The SR-71 Blackbird's 50-year reign as the fastest jet-powered aircraft might finally face a challenger. Not from another reconnaissance plane, but from a sixth-generation fighter designed to dominate the battle space of tomorrow. So, what do you think? Could the F-47 actually break the speed record? Is Mach 3 Plus possible for a fighter jet? Drop your thoughts in the comments. And if you want more deep dives into cutting-edge military technology, hit that subscribe button. You won't want to miss what's coming next.